Teacher Sense is here and welcome to a new video. This time I'll solve the part 1 of the mathematics exam of Monbukagakusho 2016. So let's do it. If logarithm in base 3 of 6 minus logarithm in base 9 of x is equal to 1/2, then x is equal to... So the topic here is logarithms. We should remember the following identities. The definition: logarithm in base b of n is equal to x, then n is equal to b to the power of x. The next identity is logarithm in base b to the power of m of n. The exponent goes out dividing the logarithm and we can introduce as an exponent of the number n. And finally, the difference of logarithms with the same base is a logarithm of the division. So for this problem we have this expression: 9 is 3 squared, and then we apply the second identity. As we see a difference of two logarithms with the same base, we apply the third identity, and finally apply the definition of logarithm. Then we have this expression, and solving we get finally x equal to 12. Next question. If alpha and beta are numbers satisfying that 0 less than alpha less than pi over 4, 0 less than beta less than pi over 4, alpha plus beta is pi over 4, it follows that the product of tangent of alpha plus 1 and tangent of beta plus 1 is... So the topic here is the trigonometric identities. The identity we should remember is the tangent of a sum, which is the following. Then, as the problem says that alpha plus beta is pi over 4, we apply tangent of both sides and we get finally this equality. Now the problem asks for the product of tangent of alpha plus 1 and tangent of beta plus 1. We do the multiplication and replace the equality with what before, cancel all the terms, and finally we get 2. Next question. When x plus y is equal to 2 pi over 3 and x and y are greater than or equal to 0, the maximum of sine of x plus sine of y is, and the minimum of that is... So the topic here is trigonometric transformations, in which we use the following sum of sines. So the problem says that x plus y is equal to 2 pi over 3, then y is equal to 2 pi over 3 minus x. Replacing the sine of x by sine of y, we get this expression as function of x. Next we apply the sum of sines transformation and finally get square root of 3 times cosine of x minus pi over 3. So we need to find the range of this expression using the restriction for x, which are the following: x is greater than or equal to 0 and less than or equal to 2 pi over 3. We subtract pi over 3 and find the cosine of this interval between minus pi over 3 and pi over 3. In this graph we can see that the cosine for the interval is between 1/2 and 1. Then multiply by square root of 3 and finally we get the maximum and minimum, which are square root of 3 and square root of 3/2. Next question. On the basis of the premises and the conclusions 1, 2, 3, fill in the left-hand blanks with 1 if the corresponding conclusion is logically derived from the premises, and with 0 if it is not. So the topic here is logical propositions. First we read the premises. There are several 3-digit numbers n, m, l, each digit of which is either 1 or 2. There are some numbers with n equal to 1 and other numbers with n equal to 2. M is equal to 2, then n is equal to 2, and if l is equal to 1, then n is equal to 2. First conclusion: if n is equal to 1, then m is equal to 1. As we can see, this is true, so it's a logical conclusion. Then we write 1. Second conclusion: there are no numbers with m equal to 1 and n equal to 2. As we can see, there is a 1 number, so it is not logical conclusion. Then we write 0. And third conclusion: there are no numbers with m equal to 1 and l equal to 1. As we see, there are 2 numbers, so it is a logical conclusion. Then write 0. And there are the answers for this question. Final question. Consider the following diagram that consists of vertices and edges. Crosses are a pair of edges whose crossing points are not vertices. Suppose that one can move from one vertex to another if, and only if, the two vertices are connected by a unique common edge. The number of routes that one can take from the leftmost vertex L through 6 edges and 5 intermediate vertices to the rightmost vertex R is... So the topic in this question is the application of Pascal triangle. We have the diagram and we need to count how many routes there are from L to R. But there is a method to simplify this problem. In this example we apply the method. Write 1 in the start point. This vertex is from one vertex, so this is 1. And this vertex is the same, so this is 1. But this point B comes from 2 vertices, so the value here is the sum of both values. 1 plus 1 is equal to 2. We do the same in this problem. Start with 1 at point L. Here is the same, 1. Here is the same. Here is the sum. 1 plus 1 is equal to 2. Here is the sum. 1 plus 1 is equal to 2. Here is the same, 1 is equal to 1. Here is the sum. 2 plus 1 is equal to 3. Here is equal to 3. This point came from only one vertex, so this is equal to 2. And here is the same, and here is the same. This point came from 3 vertices, so it is the sum of the 3 values. 2 plus 3 plus 2 is equal to 7. This point is equal to 3 plus 2 is equal to 5. And finally, the vertex R is 7 plus 5, 12. So the number of routes that we can take from the leftmost vertex L to the rightmost vertex R is 12. Thanks for watching, and please subscribe to my channel to get the newest videos. Visit my Facebook page, represents and email me for an online class if you want. It could be in English or Spanish. See you next video, part 2.